Let's go ahead and take a look at building quadratic models from verbal descriptions. In some of these problems we're going to be talking about revenue, so let's make sure we have an understanding of what revenue is and how it's calculated. Revenue is the amount of money that you receive from the sale of a specific item. It's dependent upon the price that we sell the item at and the number of units that we actually sell. So we're going to let R represent revenue in these problems. The letter P is going to represent our selling price. And we're going to go ahead and let X represent the number of items that we're going to sell. So if we want to go ahead and calculate revenue, we're going to be multiplying our price times the number of units that we sell. Now, don't confuse revenue with profit. Right, those are two different things. If we were calculating profit, we would be taking our revenue, which is the amount of money that we brought in from selling the items, and we would have to subtract out our expenses. That would give us our profit. So in most of these problems, we're going to go ahead and take a look at revenue, or how much money we're bringing in. Let's go ahead and take a look at this problem. We have the price P. We're going to be measuring the price in dollars. And we have the quantity sold. We're going to let that be represented by the letter X of a certain product. And we have a demand equation that was given to us. We have P equals negative 1/3 X plus 100. And let's go ahead and take a look at part A. We want to find a model that expresses the revenue as a function of X. So let's start with our revenue function. Remember that revenue is calculated by taking the price, and we're going to multiply it by the number of items that we sell. So P represents our price, and X is going to represent the number of items that we sell. Now, for this question in part A, it's asking us to calculate this function in terms of X. So we want only X to appear in our revenue function. And you'll notice that we have the letter P here, so we're going to have to go ahead and replace that. Now, we're lucky because we have our demand equation represented by P equals negative 1/3 X plus 100. So we're going to go ahead and substitute that in for the letter P. So we've got a negative 1/3 X plus 100. Keep in mind we subbed in, and we're going to multiply this by X. Right, now this actually could be an answer for part A, right? We now have an equation where X is our only variable in that revenue function, so you could leave it like that, or we could go ahead and multiply this out. Right, we want to go ahead and distribute this X times each term here inside our parentheses. So we've got a negative 1/3 X squared plus 100X. So either format would suffice for our revenue function. Let's go ahead and take a look at part B. We want to know what the revenue is if we sell 100 units. Now keep in mind that's going to represent our X value, so we can actually use our equation here from part A. We want to calculate R of 100. So we're going to go ahead and plug in the 100 each time we see the X here. So there's the 100 plugged in, and let's go ahead and calculate this out with our calculator. This is going to give us a negative 1/3. 100 squared is going to give us 10,000. And then we have plus 10,000. So negative 10,000 thirds plus 10,000. And since we're working with money, let's go ahead and take this out to the nearest penny. So this is going to give us $6,666.67. Let's go ahead and take a look at part C. We want to know what quantity X maximizes the revenue. So let's go ahead and take a look back at part A. Right, we had a revenue function. It said -1/3 x squared plus 100x. Notice that your A value here is a -1/3. Remember, that means we have a parabola that opens downward. So I'm just going to go ahead and give ourselves a little mini sketch here. Right, and if we have a parabola that opens downward, that means we're going to have some max value that's going to occur at the vertex. And kind of think, if we had plotted this on a graph somewhere, right, we would want to calculate what that x value is on our graph. So we're going to need the equation for our axis of symmetry, right, so that we can calculate that x value. So we've got our formula x equals -b over 2a. And let's go ahead and get our a and b values off of this revenue function. Right? Keep in mind that we had an a value here of -1/3, and our b value was 100. So let's go ahead and plug those in. We've got -100 over 2 times a -1/3. Let's go ahead and simplify this. I've got a -100 on top and a -2/3 on the bottom. I'm going to go ahead and leave that -2/3 inside a set of parentheses so that we can go ahead and divide this out on our calculator. And depending upon what calculator you're using, you might want to go ahead and type in that -2/3 inside parentheses when you divide it, so that your calculator actually performs the order of operations correctly. And we're going to get an x value of 150. Let's go ahead and calculate part D. We want to know the maximum revenue. So we're going to come back to our revenue function, and we're going to go ahead and plug in that x value that we just found. So let's calculate R of 150. So we've got a -1/3. We're plugging in the 150 for that x value, so I've got 150 squared plus 100 times 150. Let's go ahead and use our calculator to simplify this. This is going to give us a revenue of $7,500. And for part E, we want to know what price the company should charge to maximize the revenue. So let's go all the way back to the beginning part of our problem and take a look at our demand equation, which was going to help us find the price. So we've got P equals -1/3 x plus 100, and we're going to go ahead and plug in our x value of 150 right there for that x in the equation, and we'll calculate our price. So we've got -1/3 times 150 plus 100. This is going to give us -50 plus 100. So our price is going to be $50.